morning, students. Palkana Namaskar. So, in the last class, we were discussing about free vibration, forced vibration. What do you mean by free vibration? What do you mean by forced vibration? And resonance. We have discussed all the three quantities. So, in order to discuss free vibration, we have considered the example of a pendulum. When a pendulum is displaced from its equilibrium and stable and equilibrium position, say released, pendulum starts to move to and fro about its mean position. These vibrations we have called it as free vibration, and frequencies is called as, we have called it as free frequency or natural frequency. Frequencies are called as natural frequency. Natural frequency depends upon properties of the body such as length, mass, elasticity, etc. What happens is during free vibration, amplitude of vibration goes on decreasing. After some time, body stops vibrating or oscillating. Or oscillation or vibration of body damped. In order the body to be continue its motion, we have to apply a periodic force. We have to apply the periodic force. Then the body starts to move according to the periodic force what we have applied. The motion of body is said to be forced vibration. When do we say forced vibration? And body is made to vibrate due to external periodic force whose frequency is different from the free frequency or natural frequency is called forced frequency or forced vibration, or frequency is called forced frequency. When the forced frequency becomes equal to natural frequency, then the body starts to move with large amplitude, producing the large intensity of sound. It is called resonance. Now let us today discuss term harmonic. Harmonic म्हणजे काय? What do you mean by harmonic? Harmonic. When transverse waves are set up in the string by some means, by plugging or hammering, these transverse waves reflect from the fixed endpoint and stationary waves are set up in the string. Stationary waves are set up in the string. Or similarly, when waves are sent in a pipe closed at one end, and these waves reflect from the fixed endpoint. These waves reflect from the fixed endpoint. The reflected wave and the incident wave interfere each other. Stationary waves are set up in the air column as well as in the string. The stationary waves formed in the string or in air column is constrained. It depends upon the boundary condition. And due to boundary condition, it constrains on the wavelength and frequencies of the waves. स्टेशनरी वेव्ह यामध्ये जे फॉर्म झालेत ते कशावर अवलंबून आहेत? त्याच्या बाउंड्री कंडिशनवर अवलंबून आहेत. समजा हा स्ट्रिंग आहे, आपण इथं एक उदाहरण म्हणून दाखवतो. लेट अस सपोज If the string is plucked at its center and released, say first case, and released. If suppose a one loop is formed, even though the length remains same, one loop is formed, frequency is different, wavelength is different. The same length of string can made to vibrate if it is held its center and plucked, released, two loops are formed. So frequency and wavelength will be different. If the length of string is remains same, if it is held at 2 points, say, then string can if 3 loops are formed in the string. That means, depending upon boundary condition, the frequencies and wavelength of vibration of stationary waves is constrained. These frequencies are called modes of vibrations. Modes of vibrations. And frequencies are called fundamental frequency. Instead of calling fundamental frequency, they are called natural frequency. Natural frequency. So string can vibrate in different ways. Depending upon boundary condition, different wavelengths and frequencies are produced. One loop is formed, wavelength and frequency is different. Two loops is formed, frequency and different, wavelength is different. Three loops is formed, three loops are formed, frequency and wavelength are different. The frequency produced are called natural frequencies. And out of these frequencies, minimum frequency which can produce is called fundamental frequency. Fundamental frequency. Minimum frequency by which minimum frequency which are produced in the string or in air column is called fundamental frequency, and vibration is called fundamental mode of vibration, and frequency produced are called natural frequencies. Natural frequencies. या फ्रिक्वेन्सीजला आपण नॅचरल फ्रिक्वेन्सीज म्हणतो. त्यापैकी जो कमीत कमी आहे, मिनिमम फ्रिक्वेन्सी आहे, त्याला म्हणतो फंडामेंटल फ्रिक्वेन्सी. आणि ज्या त्या फ्रिक्वेन्सीला आपण काय म्हणतो, मिनिममला फंडामेंटल म्हणतो आणि त्याला काय म्हणतो, फंडामेंटल मोड ऑफ व्हायब्रेशन. हे झालं हार्मोनिक. हार्मोनिक इज द टर्म which is used to indicate the fundamental frequency. Fundamental frequency ला आपण हार्मोनिक म्हणतो. Fundamental frequency is called harmonic. And its integral multiple of fundamental frequency. If suppose minimum frequency produced in the string is n, next frequency produced are 2n, 3n, or 4n, 5n, dash dash dash. Integral multiple of fundamental frequencies, or is a first harmonic, 2n is called second harmonic, 3n is called third harmonic, 4n is called fourth harmonic, 5n is called fifth harmonic, dash dash dash. So once again I repeat, what is harmonic? Harmonic is the term which is used to indicate fundamental frequency and integral multiple of fundamental frequencies. Next, Next term is overtone. Over. Overtone. As name itself indicates, over means higher. Tone means frequency or sound. A sound which is higher than something. That means overtone is the term which is used to indicate the next higher frequency than the fundamental frequency. A fundamental frequency next higher frequency than the fundamental frequency is called overtone. First higher frequency is called first overtone. First overtone. Next is called second overtone. Next is called third overtone. And next is called fourth overtone, like this. What is overtone? Overtone is the term which is used to indicate next higher frequency than the fundamental frequencies. Next higher frequency is called first overtone, and then the next higher frequency is called second overtone, third overtone, fourth overtone, like so on. Now, let us see. In vibration of string, frequency produced are, say, fundamental frequency n, 2n, 3n, 4n, 5n. And frequency produced in a pipe open at both the ends, say like this. Frequency produced in a pipe open at both the ends. Are same, n, 2n, 3n, 4n, 5n, dash, 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 dash. In both the case, that is in the case of string in open pipe. Frequency produced are n, 2n, 3n, 4n, 5n, n, 2n, 3n, 4n, string, open pipe. So n is called first fundamental frequency or first harmonic in both the case. Second harmonic, third harmonic, fourth harmonic, fifth harmonic. First harmonic, fundamental frequency, second harmonic, third harmonic, fourth harmonic, fifth harmonic, so on. But in the case of closed pipe, if n is the fundamental frequency, next frequency produces 3n, 5n, 7n, 9n, dash, so on. Closed pipe. So in this case, n is called fundamental frequency or first harmonic, 3n is called first overtone, 5n is called second overtone, 7n is called third overtone, 9n is called fourth overtone. But what about harmonics? Harmonics are always integer multiple. That means first harmonic, third harmonic, fifth harmonic, seventh harmonic, ninth harmonic. Overtones: first overtone, second overtone, third overtone, fourth overtone. So, frequencies produced in the vibration of air column in a closed pipe are n, 3n, 5n, 7n, 9n, dash, dash. N is called first harmonic or fundamental frequency, 3n is called first overtone, 5n is called second overtone, 7n is called third overtone, 9n is called fourth overtone. In respect of harmonics, 3n is said to be third harmonic, fifth harmonic, seventh harmonic, ninth harmonic. So by this conversation, what do we conclude? आपल्याला काय समजतं? We conclude that all harmonics are not present as overtone. In this case, 2n is not present, 4n is not present, 5th, 6th n is not present, 8th n is not present. So, all harmonics are not present as overtone, but all overtones are present as harmonic. Understanding? All harmonics are not present as overtone, but all overtones may present as harmonic. So by this way, we conclude the short article, that is harmonics and overtone. Let us discuss next article. Next article is vibration of end correction. End correction. End correction. So we have two types of organ pipe. A pipe closed at one end is called closed pipe. Closed pipe. Another pipe which is open at both the end is called open pipe. When views are set up, when a longitudinal views are sent inside the pipe, these views reflect from the end points because the particles at the closed pipe are not free to vibrate. Okay? Once again I will repeat. When sound waves are sent inside a pipe closed at one end, they get reflected. Let us discuss it afterwards. They get reflected. The reflected wave and the incident wave interfere each other, and stationary waves are formed inside the air column. And the stationary waves are formed inside the air column. Always, due to boundary condition, always node is formed at closed end, antinode is formed at open end. This we have to explain. Due to boundary condition, always node is formed at closed end, antinode is formed at open end. Why? Because the particles at the closed end of pipe are not free to vibrate as compared to the particles at the open end. As the particles of the air column at the closed pipe are not free to vibrate as compared to the particles at open end. Hence, always antinode is formed at open end and node is formed at closed end. Similarly, in the case of open pipe, Due to boundary condition, node is formed in between and antinode is formed at the open end of the pipe, because particles at the open end of the pipe are free to vibrate. Free to vibrate. But Reynolds has found out that even though the particles at the open end are free to vibrate, they are not so free to vibrate. Hence, antinode does not form exactly at the open end. Slightly above it. Particles at the open end are not so free to vibrate, as you have stated earlier. Reynolds has proved that particles at the open end are not so free to vibrate, slightly above it. Hence, antinode forms slightly above the open end of the pipe. Slightly above the open end of the pipe. That means antinode forms slightly above end of the pipe. The distance between the open end and the antinode is called end correction. Reynolds has determined that antinode does not form exactly at the open end but slightly above it. The distance from the open end of the pipe and the antinode is called end correction. And end correction is given by approximately end correction E is equal to 0.3 times of D. 0.3 times of D. D is inner diameter of the tube. D is inner diameter of the tube. So end correction is given by E is equal to 0.3D according to Reynolds. Now, for closed pipe, antinode is formed only at the one end. Actually, while determining the frequency of vibration of air column, we used to measure the length of air column. Which is given by small l. While determining the frequency of vibration of air column in a pipe closed at one end or open end, we used to measure the length of air column. See. But the length is not exactly L, which should be added. E should be added in the L. The corrected length for closed pipe corrected length of air column equal to small l plus E for closed pipe, because only for the open end of an antinode is formed. For open pipe, corrected length of air column is equal to L plus twice of E, because correction has to be applied on both the sides, in upward direction also and downward direction also. So the corrected length For a pipe in open end will be capital L is equal to, say, we denote it as a capital L, denote it as capital L. In this case, capital L is equal to small l plus E on capital L is equal to small l plus E. So once again I repeat, what is end correction? When stationary waves are set up in the string, when the stationary waves are set up in a pipe in air column pipe at closed end, sorry, 1 minute. So once again I repeat, when stationary waves are set up in a pipe closed at one end, due to boundary condition, always node is formed at closed end, antinode is formed at open end. Similarly, when stationary waves are set up in a pipe open at both the end, open pipe, antinodes are formed at open end and node is formed in between. Reynolds, because particles at closed end are not free to vibrate, hence node is formed. Particles at the open end of the pipe are free to vibrate, so antinode is formed. But Reynolds has found that antinode does not form exactly at the open end, but slightly above it. The distance from the open end of the pipe to the antinode is called end correction, which is given by E is equal to 0.3d, where d is the internal diameter of the tube. For closed pipe, corrected length of air column is equal to L plus C, which is equal to L. For open pipe, capital L is equal to L plus 2E, because end correction is applied for both the side. Okay. Let us start a new article, that is vibration of air column in a pipe closed at one end. Vibration of air column in a pipe closed at one end. Vibration of air column in a pipe closed at one end. Just now we have discussed. Once again I repeat, there are two types of pipes, organ pipes. A pipe closed at one end is called closed pipe. A pipe closed at one end is called closed pipe. A pipe open at both the ends is called open pipe. So यार कातरा दिल लेके Let us suppose a vibrating tuning fork is held above the pipe open. Let us consider a vibrating tuning fork is held at the open end of the pipe. Longitudinal wave propagates through the medium, through the air column. What is air column? Air column म्हणजे काय? Air inside the pipe is in the form of column, pillar. Air inside the pipe is in the form of column, hence it is called air column. When waves are sent inside the air column, let us suppose a compression is sent. Compression is sent. Let us suppose a compression is sent from